Okay, so good afternoon, gentlemen. I hope you had a great day so far. My name is Wilfried Schadenböck. I'm working for Microsoft Center of Excellence for Datacenter, and I have a colleague with me, Philip Moss.
Hi, good afternoon all. My name is Philip Moss. I work for a company called NTTX, and we are a service provider based in the UK, specializing in public and private cloud.
So what we're going to do today is talking about the modern data center, what we understand as Microsoft there, and how we talk about cloud computing. And we have Philip here, who is doing this stuff as a daily business, as a service provider. So we're not giving you only Microsoft view and marketing on System Center and Windows Server. We show you really the real world and how it works, what people use in the field to do this. Before we get started, just to understand who is in the room, how many of you people having a title architect or doing architecture work in your companies? Okay. How many of you are doing system engineers or support? Any business decision makers? Okay, good. So is from the industry or from the segments, how many of you working in the public sector? Okay, good. How many are working at service providers, telcos? Good. Rest is enterprise. Good. Good mixture. Thanks.
Any SMEs? Any small to medium enterprises? No, right, just enterprise. Good.
Okay. So as we said, we're going to show you the different parts from a Microsoft view together with a service provider. So we're going to see the enterprise customers, how they do inside the organization, and we show you how service providers take this. So we have heard this many times, that we need to become an internal service provider. We want to explain what does it really mean, how does it look like, what you need to change, what you need to adapt. Before we begin, we started with a quick video on Microsoft Datacenter. What we do in the data center, to give you an idea, Microsoft is in a very unique position. We write software, we are a software company. We also provide services. Some of the biggest services in the world are running in Microsoft data centers, and Microsoft is running the data centers, or the biggest data centers in the world. So out of the 10 largest in the world, 4 of them are run by Microsoft. What we learn, what we use, goes back to our products and to our customers, and we help to define this. Just a quick video in the beginning, and then I will comment after the video, and we go into the detail.
Microsoft's cloud is comprised of a globally distributed data center infrastructure supporting over 200 online services, including Windows Azure, Office 365, Bing, MSN, Windows Live, Hotmail, and Xbox Live. More than 1 billion customers and 20 million businesses in over 70 countries use these services each year. Today, we're going to take you on a brief tour of a Microsoft data center and share how we ensure trustworthy and reliable cloud services while continuously improving performance, scalability, and efficiency. Microsoft operates a global array of data centers and edge compute nodes, all connected through a high-speed network. Our major data centers house tens of thousands of high-performance processing and storage servers in high-density racks. Chillers and air handling equipment ensure precise control over environmental conditions. Uninterruptible power supplies, or UPS systems, and vast banks of batteries help ensure power remains continuous in the event of a short-term disruption. Emergency generators provide backup power for extended outages and for planned maintenance, and can operate the data center with on-site fuel reserves in the event of a natural disaster. A high-speed, robust fiber optic network connects servers within the data center and connects each data center with other major hubs and internet users. Edge compute nodes host workloads closer to the end users to reduce latency and increase overall service resiliency. Microsoft ensures high availability through multiple layers of redundancy, advanced monitoring and incident response, and geo-redundant backup and graceful failover capability, all managed through our geographically distributed Microsoft Operations Centers operating 24/7, 365 days a year. We also deploy one of the largest implementations of Microsoft System Center in the world, and we use our own data repository called Scry to record power consumption and allow precise cost allocation to our internal business groups. Power Usage Effectiveness, or PUE, is the measure of total data center power consumption divided by IT, or critical power, and highlights how much power is consumed by supporting infrastructure versus the power to operate servers. A typical industry data center has a PUE of approximately 2.0, where the amount of energy consumed for the facilities and supporting infrastructure equals the energy to power the servers. Our latest modular data centers have reduced PUE significantly, typically in the range of 1.15 to 1.25. PUE is a useful metric, though we look holistically at all components of the data center and optimize for performance per watt consumed in total. Our modular approach to data center designs helps us rapidly scale to meet new customer demand, and our innovative use of free air cooling helps improve efficiency and sustainability. Security at our data centers employs outer and inner perimeters with increasing security at each level, utilizing a combination of technology and traditional physical measures. We maintain hundreds of controls across multiple levels of operations. At the data centers, technical security elements include two-factor access control, badge readers, extensive camera monitoring, and integrated alarm systems. Traditional measures can include perimeter fencing, security officers, and locked server racks. Data secured in Microsoft's data centers is classified based on its sensitivity and protected accordingly. In addition to maintaining best-in-class operations processes, we routinely bring in third parties to verify our capabilities, resulting in ISO 27001 and PCI certifications, SAS 70 Type 2 or SSAE 16 attestations, and FISMA certification. Microsoft's award-winning cloud infrastructure powers the cloud services our customers and partners use every day and delivers these services with trust, reliability, performance, and efficiency.
So the reason why I showed this video is just to give you an idea how complex the whole topic will be, or how complex the topic is. So we have seen operational components, we have seen physical components, building the data center, going into power efficiency and all these things. This comes all together when we talk about a modern data center. In our presentation, we will focus on the software side. So the interesting part is, if you look years ago, no one was thinking Microsoft as a data center, a really provider, a go-to-build data center. Also, the data center space was very, very long time, more or less very static. There's not that many changes. So Microsoft built the first generation 2 data center in the year 2007. Before, everything was more or less always the same on server racks, server cooling, electricity, batteries. With generation 2 and then the further generations, generation 3, which we introduced in 2009, we make big steps forward. We reduce the operational cost. We reduce CapEx as well. So now it is going to be a very fast living part and how we do things. We introduced data centers modular data centers, what we call Generation 4, container-based data centers. If you build a physical data center, it takes you normally around 2 years. With this modular approach, we are able to reduce operational costs much faster to the market and having also the whole cost part. So if we look now on the Microsoft Cloud Computing, what we're going to do, we start with extreme standardization. Standardization in the software, standardization in the services, standardization on the hardware. So when we talk about Microsoft standardization here on the data centers, what we do, we use commodity hardware, standard servers. We don't need high-end servers where whole redundancy is built on the hardware level. We go with standard hardware, commodity hardware. We move from the software, or then we move the resiliency from the hardware to the software. So no more 2 network cards, multiple fans, all these things. We built resiliency on the software level. So we got the whole intelligence there. We use much cheaper storage options, commodity storage, low-cost storage, direct attached storage with JPOD options. We're going to use in the networking different things, converged networking. So these are all things which allows us really to move and change the way what we do in data centers. So converged infrastructure, going into converged networks, high density, and low-cost storage. This gives us a lot of options. And that's what we need at the end, moving the resilience from the hardware to the software and standardization. That's on the first 2 parts, which is very important to be able to build the platform and having everything. In order to run operations, we all know cloud computing is about people, process, technology. So the operational part, process maturity, is a very, very big thing. We can't run modern data centers if we don't have the right processes in place. That goes with automation, change management. We need to really have healthy processes. If we automate an unhealthy process, we hit the wall faster, nothing else. I have seen in many projects service providers, telcos, who start building their offerings, but they are not ready from a maturity level. What it happened was after a certain period of time, the whole thing collapsed. It didn't work because they don't have the processes. You can implement something, but it doesn't fly for the long term. So it is very, very important in order to build a modern data center, in order to have these parts, that you have proper maturity. And you want to give the customer self-service rights. Self-service portals, they want to provision certain things on their own. You want to delegate. That's why we do the automation. I think.
Okay, let's now talk about some of these wonderful theories we've just spoken about. So, as a service provider, I care about 3 things, only 3 things. Requirement 1, delivering a service that meets my customers' needs. Requirement 2, driving down the cost of delivering that service. Requirement 3, making money, because IT is my business. You know, at the end of the day, if I don't make money, my staff don't get paid, my family doesn't get paid. So driving a service that meets my customers' needs and driving down cost is everything to me. It's a very different paradigm for service providers. So let's just talk about how we use technology to achieve those things. So we, as a service provider, provide a vast array of services. Crudely off the top of my head, it's Exchange, Link, SharePoint, RDSH, thin client, VDI, virtual desktops, physical machines, virtual servers, and CRM, to name just a few of the applications. Now, that's a very broad range of services we have to deliver. And we have to deliver those off of a unified platform. Now, to deliver those services, we have a number of goals we have to achieve. First of all, we have to deliver high availability. Right? Has to be highly available. It has to be 100% automated. Right? And it has to be 100% virtualized. Because if it's not 100% virtualized, I can't deliver these diverse workloads. So we've got these three high things: high availability, 100% automation, and 100% virtualization that we have to deliver up here at the application layer. But to do that, we then have to build from the bottom up. So we talk about this extreme standardization. In the old days, what people used to do is they used to go out to their storage provider, and they used to get a nice expensive storage solution from their SAN provider, and they used to pay them a large amount of money for some support and some value-added software. And when they went out to their network provider and they bought some very expensive switches, people are nodding their heads, I'm sure you've done this, and who spent $40,000 on some nice software to manage their switches? Yes, I see some smiles in the rooms. And then, and then on top of all of that, you probably went to Dell or to HP and bought some big, fat, expensive, I see some smiles down here, some expensive servers, yes. People have done this, yes? Right, good, okay. So the problem with that approach is the cost to serve goes up like this, and you have zero flexibility. So what we do inside of NTTX is we have complete standardization on completely modular commodity hardware. So at our storage layer, we use technology which is introduced in Server 2012 called storage spaces. Anyone heard of storage spaces? Storage spaces, right. Technology built in Server 2012. Highly recommend attending some of the sessions later on this week. That allows us to drive highly available scale-out storage on industry-standard cheap JBODs. Right. We then build on top of that a continuously available scale-out file server, again built purely on Windows. We then use the native networking technologies built into Windows for teaming and load balancing. And then we build large hypervisor clusters, yes, large 63-node clusters that are being able to pour very, very, very large amounts of compute workload in there. Right? So what that allows us to do is allow us to build this end-to-end stack, right, built purely on commodity hardware and using the software layer, Windows, to drive the management. Right? So much so that in the 2012 cycle, we actually completely mitigated middleware, completely. Went completely from our system. Now, you might wonder how we managed to do that. Well, the key difference is we now drive that automation piece. We use the automation capabilities built into Windows to allow us to do end-to-end management, yes, of our entire system. Because I started off this section talking about the fact we deliver Exchange, Link, SharePoint, physical machines, virtual machines. For us, they are services to the end user. And what I'm always interested in doing is driving forward those services to the end user in a way that they can just consume them and ultimately self-service provision by the portals that we built for self-service provisioning. That is the way we do our business because that allows us to drive down our cost and maximize our revenue. This is the way modern data centers are built. Oh, and by the way, we started doing this in 1999. So this is not new to the service provider sector, and that's the really important thing to take into this.
Okay, so just to give you some stuff, because we had the storage or something, using storage spaces, using internal technology allows you to reduce dramatically the cost. When we think about SAN storage, we talk about $10,000, $15,000 per terabyte, depends what kind. When you talk about direct attached storage spaces, you're talking about $300, $400, $500. So it's a huge amount.
In fact, let's talk about that just on the storage front. We are now running at 20% of our storage operational costs than we were under SAN. So we are at an 80% operational reduction in storage costs from where we were on SAN hardware. Okay? Then we are delivering a better service than we are for traditional SAN. And that is an enormous saving.
So what I see in the field in my job, so I'm traveling around. I have been in 60 countries in the last 1.5 years. So you work with the top customers and all. And what we see with a lot of service providers even, they come to us and say, Microsoft, I want to reduce the cost because it costs me more provisioning a new user or the new customer than I earn at the end. There are the things like storage costs. There are a lot of costs hidden in the automation versus manual stuff. We will see more on this later. And that's a key thing. So you need to have standardization that you can do automation. If you don't have standardized services, it's almost impossible to automate them. So in order to move forward, that's just a few of the services we were mentioning. We were often being asked, what is Microsoft's definition of cloud computing? So Microsoft is not having their own definition of cloud computing. We are leveraging the definition of National Institute of Standardization in US, which has 5 characteristics. We see here 4. The one which is not shown is broad network access, pooled resources, self-service, elasticity, and usage-based. These are the 5 key characteristics for private, for public, and for hybrid cloud. Doesn't matter. This describes a cloud service. Microsoft adds on top of this for the private cloud 2 things: control and customizable. That's the key value you want to do on the private cloud, and Microsoft technology will allow you this. We will see this in detail a bit later when we come here. So when we talk to customers, I mentioned before, one of the challenges they see is cost of their solutions in order to provision new services, time to market. Another big thing is business owner and application developer, service consumer. Many times in enterprise customers in large organizations, what we see is that service owner move outside the organization and say, for me it's cheaper to get certain services outside than I get internal in my own enterprise organization. I'm not sure if you have seen this. So if you work in a lot of big enterprises, it's very common. They can get a certain budget. They can consume where they want. But often, the internal service is much more expensive than the external one. Plus, the other part is, if I go external, I know I get it fast, and I know exactly what I get. Not, I need to look, I don't know. And that's one of the big challenges what we see in the field. That's many enterprises facing today. And I think that's one of the parts, and that's why we have, for example, here now, Philip. That's exactly his business. He's coming and say, I'm a service provider. I have for you your custom solution. And that's exactly where he comes into the picture. He is coming with a tailored service catalog and go to the customer, meet the customer and say, you want service XYZ? I have it tailored for you.
So, and this is actually the biggest advantage, and also before you get your pitchforks out and start stabbing me for being the reason that you're going to lose your jobs, that's the point. I come with a service catalogue, and I come with a broad range of capabilities. There's a driving high availability and a fantastic service cost because I've driven this stuff down. But what I can't do is I can't be inside your business. I can't understand the unique requirements of your business. What I can't do is integrate with the line of business apps and all the additional services your business is trying to do. And that is where the modern data center and the modern enterprise IT platform can drive value. And that is the future of these platforms, to take the learnings about automation, this end-to-end solution, something we'll talk about more in a while, and actually bespoke it and build a solution that actually meets your exact business needs. Yes? And that is how you drive forward the value proposition inside of your enterprise, to drive forward the value proposition of your business.
So the offerings he is offering is something 80-20%. He's focusing what the majority of standardized offerings need, or the customer's needs. Email. Email is a service which is not highly customized. SharePoint. If you use SharePoint for certain areas, it's a perfect service you can offer.
And others, it really isn't. Yes, there's whole sectors of SharePoint we can't touch.
So if it goes to highly customized and application and all this stuff, then service provider might not be the best solution. And that's exactly what we try here to say. You have certain things which are very much standardized you can consume, or people might consume from service providers. But as an enterprise customer or an enterprise internally providing these services as an ID, you have values. That's a little bit the same conversation with global players and local service providers. So there are certain areas where you say you have much more insight, you can do much better customization, none of the service provider will go and invest in a huge thing which 5% in the country will use.
It's not cost effective.
They want to earn money, so they focus on the big stack. And that's exactly the part. IT will change. The modern data center will change. Our operation will change because we need to do certain things in a different way in the future. So this, exactly what we are having here, is, when we go back to the slide before, gives you control and customizable if we use Microsoft Private Cloud. That allows you to do things which you can't have from the outside, which you can't get from a service provider, either a local service provider or a global player. So in the part of the modern data center, we have two key roles, two key players. The service consumer application owner, as I mentioned before, and the service provider data center admins. That's in a typical enterprise scenario, same in a service provider. But if we look, that's our key players. Both of them have different areas which are interesting for them. Data center admin service provider is interested in resource pooling. I want to use as much of my resources as possible. It doesn't help me if I have multiple servers, each one is running 10%. That's one of the things where we try to get as much as possible out of the resource pools. And we will see later as well, it's not only storage, server, and network. We want to talk about really the application, what we are providing there. Delegation and control. Everything which I can give out of my hand saves me work. So if you think about in your enterprise, what is the most common ask in the help desk? What most people ask usually?
Come on. Top 5 help desk questions. Password reset. Good, thank you. Anything else?
That's number 1.
So there's one. What else? Top 5 requests coming into your help desks. Or do you have IT systems that never go wrong? Sorry, forgive me? Okay, print okay, good. Sorry, gentleman at the back? Good, right, good, yes. Right. Actually, that's a very good one. Computer, anything else? Sorry? Okay, fine. Deploy applications. Forgive me, can you repeat that? Right, yes. So and then security permissions. So security and access. Okay, so there's 5. So let's talk about those 5 briefly for a second. We have 5 problems there. I don't think anybody mentioned the back-end server component. I think all those problems were user-related. Yes? Because ultimately, we build systems that provide services for users. Right? Our job in IT is to deliver stuff that allows people to do things, print documents, write things, buy things online. Yes? Our job is not actually to worry about servers. Now, let's use a good example here about delivery of solutions. Let's think about creating a new user. Yep. I assume most people in the organization have to create a new user. So you've got a new starter. Yes, we've got some nodding of heads. Now, let's think about the workflows involved in adding a new user. So you're going to have to do some work inside of Active Directory. You're going to probably have to create some Exchange account for them. You're probably going to have to rig up a directory list. You're probably going to have to do some security permissions on some file access rights. You're going to need to give them some applications. You might need to use things like AppV, use environment virtualization. You're probably also then going to have to do things like give them a device to go and connect from, right? Which could be a PC. It might be a random iPad they've turned up with. Oh, and you've got to go and get documentation onto their machine to tell them how to go and do it, and you've got to educate them and get their username and password to them. All these things sound familiar? Some nods in the room. Good, sound familiar. So there's a number of ways of doing this today. And depending on what organization you are, you'll probably have playbooks for staff. Staff how to do things reliably, playbooks, yes. You might have some form of automation, either stuff you've written yourselves or through some management solution, for example, System Center. But the challenge here is that you can't, if you're using playbooks or you've got manual intervention, you won't necessarily do it 100% of the time. How many people get support calls that kind of say, well, this was set up, but it doesn't work? I'm seeing some nods around here. Yes, okay. So the more manual a process is, the more prone it is to having problems. The more problems you get, the more support calls you get, and it's a vicious circle. So the real value add here, when we start talking about delivering these services to these users, is if you do 100% automation, you eradicate user error on setup. And also, if you're using 100% automation, you can then enable user self-service provisioning. And this is the really key thing. Because self-service provisioning isn't let's go and stand up a virtual machine or let's go and install a Exchange server. It's I'm Jane in account and I've just started work. I can create my own user account. I can assign myself the services I should have, but I can't assign myself the stuff I shouldn't have. And I can make my machine work. Right? That is what true self-service is. This is how I operate as a service provider. You know, our users, our customers completely self-provision, and they've done this now for over 12 years. This is the only way I can run a business. Now, who here has operations staff? People who physically go and use server admin consoles? Got some hands coming up. Okay, good. So someone a few weeks ago asked me how many operations staff we have. We have 0. Absolutely 0. I don't have a single member of staff who physically goes into a server room or physically goes to a server console and does any work. All of our staff, including our admin staff, operate out of our management platform. Now, why is that important? Well, because, again, if our admin staff run out of the management platform and our end users use the management platform, you don't get user error. You don't get misconfiguration. You don't get problems. You also get 100% auditing and 100% tracking of the workflow. Right? Those are enormous productivity gains. In my business case, that allows me to drive my cost to serve down, allows me to make a profitable business. In your case, it allows you to actually run known cost centers and actually be highly efficient as a business. But automation and this understanding that there is a user end and there is a fabric end, that is the key understanding. And understanding how they integrate together as an end-to-end solution is absolutely key.
And this is defined by the service agreement. We will see later a little bit more in detail on this. So delegation and control is really the thing, as we heard. As much as we can delegate and give the users the permissions, the actions they can do themselves, that's help us. Just think about resetting a user password. We had one of the things as the typical service desk call. If I can give the user the possibility to go to a website or use the phone or whatever to reset their password, the user is much more happy because he can do it fast and quickly without calling someone, without waiting and delay. And I'm happy I don't need to worry with 70% of my help desk calls. I immediately reduce my time spent there, and I can focus my time on doing more important stuff. Cost efficiency had what we had before, and on the other hand, we had self-service experience, and of course, it needs to be simple. My end users in the organization are not necessarily IT people. If you go and tell the HR lady, sorry, I can't provision a new user because of the SAN environment, we don't have enough space, she might not understand. She says, we have a new guy starting at this point, I need to have all the things ready. So that's things, it needs to be simple, understandable, and they can use it on their own. And we have clear service agreements. I know when I do something, I provision something, how fast it will be provisioned. I know how fast I get service response in certain cases. I have exactly defined what I'm getting for the money I pay internally or how it is cross-charged. When we look now in these areas from the technical point, we combine them into 3 bigger building blocks. One is the application management. You have most probably often heard Microsoft saying it's all about the application. That's true. That's most probably where most of the customers or most of the enterprises earn their money with their key applications. I want to make sure I can manage them, I can monitor, I can control them. We have seen service delivery and automation. That's the key what we focus on here now. How we can automate, how we can do the service delivery. and the infrastructure in the back end. What servers are we running? Physical, virtual, private cloud, public cloud, hybrid solutions? That's at the end the big part where we look all these things. And if we look how the different stakeholders are looking, the application owner wants to have service delivery and, of course, wants to understand what's going on their application. So they have different things what they are interested in. Self-service monitoring. My end users want also to know what's going on their application. We had the example, my PC is slow. Might be the same with my key business applications. If my application is slow, if I have an application, a web application where I'm selling something, if the people are not able to open the website in the first seconds, they might not go there. Think about yourself. It is annoying. You don't open a website, you don't go somewhere. If you have to wait 30 seconds that Amazon.com would open, you would not buy there. It is the first impression, so it's important that the application owner, the business owner, knows what's going on the application. Data center admin, service provider. We are focusing on other parts. So we have the whole management, server network administration, the services, and process automation. So we had before, again, standardization, automation. If we go into this part, there's always a kind of trade-off, especially in the enterprise. We all know there are some VP users, they always want to have the extra thing, and that's challenging. The more extra things you have, your whole automation will fail. So you need to have a standardization with no exceptions. So when we look now in the Microsoft approach for the modern data center, how we do these things, we heard about our self-service. That's our service catalog. And that's where we build the options. We heard before. We have Link, we have SharePoint, we have remote desktop services. We have the whole bunch what we are doing there. And that's very important to understand how to build this service catalog, what are my service dependencies, and later, how I'm going to deliver them. We need processes, we said very clearly. Most probably, you have some written form, some policies, how to do it, but it's not enforced. So by going into a modern data center, doing automation, you will need to enforce them. You need to have standardization of this. And then we deploy. Again, it doesn't matter if it's physical, virtual, private cloud, hybrid cloud, public cloud. It can be anywhere. Microsoft System Center has a very, very big advantage. We can connect private cloud on-premises to public cloud. This will come in the future more and more. If you listen to Gartner, by 2016, 35% of the enterprise customers will have some kind of hybrid solutions, which means a mix of purely on-premises and consuming services from service providers. Doesn't mean if you consume certain things that you don't have control about it. Think about applications. You want to have application, certain things will run on-premises, and front-end might run in the public cloud. But you want to monitor, you want to see what's going on.
Let's bring that out a bit more. And this is the really key thing. So we touched on this self-service portal idea. And this is why, by the way, you didn't have to have the pitchforks out for me. If we look at that user, Emily, what she cares about is that service consumption. Yes. What you care about is the automation stack in the middle. But where you source those services from actually doesn't matter. And the real power of where Microsoft is moving a lot of its software stack to is if we look at this middle section, this service and delivery automation piece, it's now becoming very, very, very easy to change where those external components are coming from. And we spoke earlier about this dynamic flexibility. Well, dynamic flexibility you need around storage, compute, or mailboxes, or SharePoint sites. One of the real beauties about where Microsoft has moved a lot of its software stack to now is that if you need to take more storage from the cloud, or you need to take a service from the cloud, you can. Right? And you can integrate it directly with your on-prem to give a unified experience to that end user. Because ultimately, Emily is the person who just wants to get on with their work. Yes? And that's the absolutely key thing to drive home. And that layer you drive in the middle is where you're driving the real value. Yes? And you are consuming and using the building blocks effectively. Yes? They might be on-prem, they might be external, they might be public, they might be private cloud, they might be pure services. And that's why there's this very wonderful ecosystem Microsoft has built around this. And by the way, Microsoft is unique for this. Remember, I know I'm wearing a blue shirt, but I don't actually work for them. If you look at the advantage Microsoft has over some of the other competitors, because they build the client OS and because they build the server OS, they can build that integration directly into those platforms you use on-premise today and give you a nice integration with the outside world. And that includes people like us. It doesn't just mean going off to Azure. And that's a huge value proposition for the enterprise, both today and as we go forward for the next 4, 5, 6 years.
So once we deploy the whole thing and configure, of course, we want to monitor and operate. We want to know what's going on, as well on the infrastructure side and also on the service delivery side. So that's the key thing. So if we go further now, that's the concept: service catalog, automation, and having our data center. And the key thing is that doesn't have to be all pure Microsoft. You will have different things on a physical world. You might have different hypervisors. You might have different cloud providers. The key thing is here heterogeneous management. Microsoft calls the management here the fabric management. So we are managing storage, network, and compute. And key thing is heterogeneous, especially in the bigger environment. There's nothing like a pure Microsoft data center. Let's be honest. Even Microsoft is using things from other vendors. Can't be everything on our stack. So the key thing is to have one single tool to manage and integrate. And that's the key thing. You have your self-service. That's your presentation layer. That's where you go and do your requests. Yes, you can buy multiple tools, bring them all together, will work. But it takes a lot of time for customization, for integration, and getting the things done. The value is here, out of the box. The components within Microsoft easy integrate with each other. You have predefined connectors, predefined stack, and also the presentation layer, the self-service portal. It's very simple to create self-service requests, to publish them. Yes, as we said, it's possible to develop, but this takes quite some time. So that's the key thing. So it's easy, very quickly made, and delivers you a huge part of your solution, which you can use very quickly. So we're going to look now in the two areas of the infrastructure management and service delivery. So infrastructure management has several things. Provision the infrastructure. Once we build our solution, we need most probably to grow. We need to add additional capacity on the backend side, so new servers, new storage. But we also want to provision new services to our customers, create shared infrastructure, automate the service delivery and offering, and later the management part. So when we look at the infrastructure side, we use one tool to provision physical and virtual servers. You don't need two different tools, two different set of people doing it, training the people to do different things. The whole key thing is, in a modern data center, you want to have one set of administrators who is able to run the whole thing. Think about in a traditional world. You want to provision a new server. This goes with a service request for the server. then most probably do the network people, most probably do the storage people. That costs time, multiple people involved, very much silos who is treating which part. And this is completely changing in a modern data center. I think we will hear a little bit more on this.
So let's talk more about this different skill set. So historically you did. Who has a storage team? Sure, we're going to get some nods in here. And the networking team? Yeah, and you probably have a physical server and a hypervisor team of some description, either VMware. Right, okay, good. And those teams isolated, don't talk to each other? Yeah, nods, right, yes. Who's had this situation? The hypervisor team say they want a VM of size X, and the storage team go, oh, no, can't do that. We haven't got the IOPS. Haven't got the storage. Yeah, I'm seeing some nods. Right, okay, familiar situation. And by the way, the network people in the middle go, I can't do that because it's not supported on IP6, which I've just rolled out because I've got some new switches. Yep, good, okay. So this is why we have to fundamentally change the way we view data centers. I don't have a storage team or a networking team. Right? What I have is a team of engineers who understand our end-to-end stack. And when I say end-to-end stack, I mean that's down to the user having an individual mailbox. I mean the end-to-end stack, because as I spoke at the beginning of this session, it's about end-user services, not about the fabric in the middle. The fabric in the middle is a slave. Now, where it gets most interesting is that I had a team of 8 people. We have a wonderful management platform that allows us to do everything from bare metal deployment, configuring our switches, fill our hypervisors, delivering our application layer on top, Exchange, Link, SharePoint, and configuring the entire user experience. And it does our entire billing, chargeback, and everything else. Well, it's a fantastic platform, and it should be, because I had a team of 6 engineers spend 8 years writing it. Right? So it's very good. Now, for my business, that's a non-brainer because I need the solution to go and deliver it. Now, one would hope in the enterprise you don't want to go and invest that time and resource. Actually, I have met enterprises do it, but it doesn't make a lot of sense. Where it gets really interesting, where Microsoft are today, is that with System Center and some of the evolution that's happening in System Center R2, they're now driving that end-to-end stack because what Microsoft has now really grasped is this understanding of end-to-end solution. So System Center is now becoming your one-stop shop to build out your core infrastructure, that storage, that network, that compute, and then to drive that self-service portal at the end for the end users with the application layer in the middle, that configured Exchange server, that working Link implementation. And the other nice thing about System Center is that now that platform is interoperating with external providers, be it Azure or people like us. Yes. That is a huge win because enterprises can take this platform as a turnkey solution and instantaneously take all the advantages of the modern evolution. Now, there's one other thing I'd like to talk about briefly in this area. We touched on the fact that you can't take everything on the Microsoft stack because there are other vendors, and I'm sure many of you have multiple vendors in there. Has anyone heard of DAL, Data Center Abstraction Layer? Okay, lots of deaf looks. I would highly recommend following Jeffrey Snowden's talks on database abstraction layer. I'll cover this very briefly because it's very important as we move forward into the future, where we now start to consider all devices, switches, firewalls, routers, printers even, right, having a unified set of addressable components so that we can get hold of these technologies and manage them from System Center or from PowerShell in exactly the same way as we do Windows servers. Now, what that will allow us to do, and enterprises, is to actually bring under one management roof all of those diverse components, yes, and finally get rid of this multiple management frameworks, multiple management interfaces that we have today, and critically allow your staff to focus on the end-to-end system, yes, not on storage team, networking team, hypervisor team, who never talk to each other. Think system, think end-to-end experience, and that's the fundamental change.
And you see already the industry picking this up. More and more vendors integrate completely PowerShell in their management stack. If you look at Cisco UCS Blade, you can automate from scratch completely. They have more than 1,500 commandlets implemented. So you can completely from zero to provision the whole thing, configure Cisco UCS Blades with PowerShell. It's amazing.
Sorry, yes, I interrupted you. Let's talk about that Cisco experience for a second, because one of the things, if I go back 10 years, one of the things we had to do was we had to write different bits of automation code for these various subsystems from different switch vendors, storage vendors, etc. And we spent a lot of time and effort doing that. For the last 2 years, we will not have a platform. We will not have a hardware platform in our system that does not give us PowerShell access. Yes. It is now a requirement for any vendor we use. Yes. Because that level of automation and the simplification of the automation has become such a key part of our solution. And this is what we're touching on. As you go forward, you should look for the vendors who support these technologies, because you'll get the automation and you'll drive down your cost to serve and you'll drive up your availability, which are the two things you really want to achieve. Sorry, man, I'll let you carry on.
Yeah, no problem. Yes, so you get the complete stack of the commands, you get the explanation, and PowerShell has the help files. PowerShell is very easy to understand, so you can have all the about sites, which explains every single command in itself, plus the help file itself. So if once you understand the stack, how it works, it's very simple to find around the way in PowerShell. Plus they provide sample codes and all this stuff as well. And there is a lot of material out which shows already samples.
Yes.
So there are multiple network providers coming into this now. So F5 network, A10. So you see on the network stack coming more and more, as we said, on this server stack as well. So there's more and more industry support going for this.
And over the next 2 years, it will increase dramatically. So come and talk to me after this session about some of the changes in storage, and we'll talk about some of those commoditizations. There's a very wide conversation. So it's slightly off this topic, but there's a huge shift in the storage industry.
Yes.
Right? And especially in some of the stuff Microsoft did in Service 2012, which is probably a 4-day discussion in its own right. So let's have that conversation after. If anyone wants to talk about storage and scale out storage, let's talk about it after the session. But more than happy to have a long conversation about that.
It's
a huge subject.
It's a huge subject, and at the end there's a lot of things going on. Microsoft introducing storage spaces and all this. Storage is a high margin business and a very good business. So certainly Microsoft comes and says, you can use JBOD disks and you get the same performance using it in an intelligent way.
Right. Let's cover this. So very, very, very briefly, the big jump forward in Service 2012 was to go to what used to be called, well, now called continuously available scale-out file servers, using a Windows server, right, to deliver storage off of a cheap JBOD using storage. Then using SMB 3.0 in the middle tier of your network stack over cheap commodity switches, going up to clustered hypervisors, yes, where the VMs are pointing to a VHDX on your scale-out file server. Highly modular, very cheap, very, very, very efficient. It's how we build our 2012 data center. And let me just, right, we're going to an engineer conversation now. There's actually a session later on this week, by the way, on this very subject, if people want to join it. It's a session on Thursday I'm running. But very briefly, we slashed our virtual desktop delivery costs from just under £27 sterling per month, operational cost, to under £10 operational cost. Yes. The reason for that was the 80% reduction in our storage costs, yes, the throwing out the expensive switches, yes, and the standardization on very, very, very cheap commodity hypervisors. Right? In our case, we use Dell hardware. Yes. And 2012 and the other key part of 2012 is we also managed to standardize on PowerShell as our end-to-end management stack, which meant we could throw out a lot of those third-party automation pieces. Yes. And actually, this is the thing that I was just talking about a second ago. For us, we had to build our management platform, but where System Center, brilliant. The System Center drives real value is that it actually, thank you so much, allows you to, it allows you to think about this storage, network, compute, but take this unified management piece over the top. And that's where there's a huge gain under 2012 and where System Center drives real value. Anyway, I shall let you go back into the thread. Yeah. But we can happily, if anyone wants to have a conversation about actual data center design, we can happily do it afterwards. Or as I said, there's a session on Thursday.
For example, last year we showcased in TechEd Amsterdam the 1 million IOPS. That's based on this technology using, at the end, storage spaces. So Jeff Woolsey showcased on a single machine using SSD drives. Yes, we needed multiple SSD drives, 45 SSD drives with specific LSI controller, but we had a system which costed less than $50,000 just to show 1 million IOPS. I mean, that's a huge number just to showcase, But it's not about that we don't reach performance. The key thing is you have the right kind of storage for the right applications. And that's what we can provide. Certain solutions don't need high-end expensive storage. If we need high-end storage, high-performance storage, we can still use SSD drives and all these things. So that's building the whole solution.
Well, let's talk about those SSDs for a second. So the big change that's happened in 2012 R2 is that storage spaces now supports tiering, right? Which means you can now tier between SSD and non-SSD to give you very high performance with very efficient cost efficiency. In fact, my team's been doing a lot of testing on these technologies over the last few months. We also now factor in things like deduplication, right? So for certain workloads, you can get very large amounts of deduplication, for example, for things like VDIs, personal virtual desktops. Very large amounts of deduplication coupled with tiered storage allows you to use a small number of SSDs to drive performance and then backload large amounts of data onto HDDs. But all of that's on the Windows stack. Now, we've actually rapidly ended up in the storage conversation, so we'll go back on subject. But again, there's a conversation later in the week about this. I would also highly recommend if people are interested in this in joining Brian Matthews' sessions on storage spaces, which I think are Thursday and Friday of this week. So I'd highly recommend those sessions, which I think I'll also be in if these questions come up again.
So just to summarize what we said so far. So manage multiple different heterogeneous hypervisors, one management tool across heterogeneous environment, deploy consistent services across platforms, and that's what we do in the infrastructure space. That's one of the enabler. It's just one, as we said. So we had a lot of discussion just on the storage. So if we look now on the service delivery and automation, that's what we said before. We need high level of standardization. So we need really to look what are the services we're going to provide, what will be our service catalog, and how to standardize this. What are the different request offerings? Then, of course, we go into the automation and design the workflow, the approval, automatic, or do we need someone to approve it manual? What are the notifications behind? So that's one of the very, very key things. That's where we save money. That's where we also do automation. We avoid human errors, and we save time, and we can focus on more strategic things. So there's one very important thing. All what we are talking here needs to have a certain size. The approach what we are doing doesn't make sense if you're a small company having 100, 200 users. So there is a critical mass where we need to say that makes sense that we automate, because automation takes also time to invest, to build this. But once we have this, that's at the end where we look into it and say, okay, by having certain things what we're going to use over and over again, fully automated, that's going to help us a lot here.
As a guide on size, Microsoft kind of says, if you've got under 500 users, you're probably better using the tooling they provide. Yes, over 500 is where that critical mass starts to hit. You know, in terms of building the automation, the way you start to really get the advantages. We have some smiling faces down there. It's always good. Come on.
So when we start with our standardization, we have one key thing, which is our CMDB. We're going to have different templates what we're going to use and runbooks later for the automation. We had the example with creating a single user. We came up with 10, 15 different tasks, depends how complex in your environment is, which needs to be done in order to automate it. So we start with the service catalog, with the service portal. And that's, as we heard before, is more or less a lot of work already done for you. You create your service request, you can publish on this self-service portal. There are other third-party vendors out of it. It takes a lot of time to customize, to develop. You can develop on your own. So that's the part. A lot of the stuff is coming already out of the box. So we have our service catalog, and we can publish easily our requests. That's where the end user goes, where HR say, I want to provision a new user, whatever it triggers in the background there. So this is at the end what it will trigger, where we create the user. Active Directory, Exchange, link, do we need to create it in the HR database and other stuff?
Let's have a look at that, because what you're looking at there is something very powerful, and people often skip over what they're looking at here. So what we're looking at here is that business intelligence piece, right? That's the piece that your runbooks do today. That's the, I have to do this before I do the other. Right? Again, I'm getting some nods in here, because as anyone who's actually done this a lot, just saying it's an AD object and then it's an Exchange account doesn't really work. There's a lot of business intelligence about getting the stuff in the right order. And what's being driven here with the orchestration layer built inside System Center is it's become very easy to build that logic and take the intelligence you already have inside of your business and build the automation around it. My engineering team had to write an entire logic engine to go and deal with this. And Microsoft's now driving this stuff directly in Box. The other nice thing about the automation, the orchestration piece, is that you can easily change and you can build in components. Right? So as needs change, as you have new services for different users, you can build that automation, that orchestration piece, thank you so much, very, very, very easily. Your timing's good today. Yeah. And you can make the modifications, you can understand the workflow for different scenarios. And that's a huge win, and there's very little investment you have to make in terms of development time. We've had some comments about where's the PowerShell piece fit in. Well, the other thing which is so nice about this is you can take PowerShell from external sources. You can take the automation you have written and build it into this workflow. Right? So you don't just have to take stuff that Microsoft's given you. You can build all that other automation, and in fact, even manual process if you really want to, and you can build it into this orchestration piece, which is hugely valuable for this modern data center design.
So how many of you know Orchestrator or Obalis? Okay.
Excellent.
Good. So Microsoft bought Obalis in 2008, which was was the leader at this time with data center automation stuff. We had a lot of integration packs with third party, so we had more than 50 different parts where Microsoft can easily integrate with HP, IBM, DeWalt, whatever you call them. So the most common ones. And that's at the end the tool which we use internally to extend our own stuff, how we can connect monitoring system into our service management. We get an alert. We can automatically, based on certain actions, create a trouble ticket. We can do proactive checking and do things which we used to do normally, like a checklist. Web service is down. Okay, try to restart. Try to do this. That we can all predefine and work automatically to fix things. That's the tool which we use. And it uses for the automation of the processes. So it's a very powerful, very cool tool. And still, it has all the integration packs coming they're there, so you can connect to the different systems. So again, just as a summary, so we have the request, enter the request in the self-service portal. We automate the whole thing in the background. We have approval workflows. And then if the whole thing got through the workflow, if it's approved, we automatically deploy the whole thing. This allows us really to have predictable delivery of our services. So we know exactly every time someone requests a new user, it is exactly the same. I don't need to think, did someone forget something or something? It is always exactly the same. Good. Once we have deployed the whole thing, we also need to monitor it. So, same as we had on the provisioning, physical, virtual servers, the same set of tools. It doesn't matter if it's Microsoft, VMware, Citrix. We can manage, monitor the whole environment. Microsoft Operations Manager is the tool which helps us on the monitoring. Is completely heterogeneous. Connected with Orchestrator shown before, I can do proactive stuff. So it's not only the infrastructure, what we see here, it goes even to the network devices. We can monitor network devices. As we said, we want to provision one end-to-end application, so we need to also understand our network in the background. So that's coming all out of one tool. Maybe not everything is coming out of the box from Microsoft, but we have a very huge partner ecosystem where you can integrate additional things into our tools, like on the monitoring. You can use other solutions from Veeam or the management packs to integrate managing VMware. We can do batch management across heterogeneous environments, not only Microsoft. We can batch Linux, Unix, Apple iOS. So that's very important. When we look in the monitoring, we can monitor services, not only servers, not only simple red and green signs. We can really monitor the health of applications. It says what is currently the health based on availability, configuration, security, and performance. So we describe the health of our applications of services. This is just showing on the heterogeneous piece out of the box from Ops Manager. We can monitor different operating systems, different application platforms, different databases. So it's complete heterogeneous monitoring in one tool. Yes, Operations Manager. Important thing is, in this as a summary, to proactively monitor and the heterogeneous part. So we want to know before something happens. We might need to shift workloads to different nodes. We want to give our customers, our services, what we have been agreed. So it is important in a modern data center to have the flexibility to move workloads without any interruptions, to provide always the services to the customers. In a big environment, you don't know on which hypervisor your virtual machine is running. You know it may be on a 4-node cluster, 8-node cluster, but on a 64-node cluster, no chance to know where one of your 1,000 VMs is running. No idea. And it doesn't matter. It is a black box. It is running there where we have our rules. It has the best performance, which is there. We know it can run together with other machines. We can define affinity, anti-affinity rules. We can define priorities on moving, on starting. So we need to make sure we describe the whole environment is healthy. But if it's running on the node 64 or on the node 32, it doesn't matter.
Okay, so let's just talk about some of that logic. So the question, by the way, was, do we as a service provider, and forgive me, I'm going to paraphrase this slightly, do we as a service provider control actually where we're sticking VMs, or do we effectively let the cluster kind of deal with what's going on? Simple answer is, yes, we let the cluster do it. Now, so let's talk in practical terms. We have some very large clusters, and we literally poured thousands and thousands of VMs into them. And what we do is we let the cluster distribute the resources effectively. We do use that affinity and anti-affinity, but the way we're using it is so we do things like, are people familiar with Exchange, DAG, Database Access Groups? Good, we've got some nods in here. So we do things like we make sure that you haven't got both servers in a DAG physically on the same host. Because if you lost that host, you'd have lost both of your DAG servers and you would have lost the application high availability that we talk so much about. So the simple answer is we use the affinity, anti-affinity to make sure that we don't reverse ourselves into a hole about VMs being on the host that could fall down, therefore you lose the whole application layer because of all VMs. However, we let the cluster itself actually deal with the resource management and use logic built into it.
It's very simple. He wants to sleep. Or
yes, exactly. And I'm lazy.
We don't know. Is it happening 2 o'clock in the morning or during the day? So at the end, yes, we leverage the intelligence from the computer and ours and let them do their work. That's why we have them. In the beginning, in the enterprise, yes, there's some learning. You can control how aggressive you are shifting. Once you have the full trust and you know it's full, you will automate more and more.
It's also worth noting as a service provider, we run our hypervisors at 90% utilization. Because we can, because we have 100% automation. So we can move stuff around very easily. Because remember, it's back to this bang for buck or this cost perception. I'm trying to drive down cost. Therefore, I flog my assets and I sweat them very, very, very hard. The other thing, which I don't think we've touched on here, but it's worth thinking about, is also I provision all of my hardware just in time. What enterprises used to do is enterprises used to go and buy $2 million worth of hardware and have it sit there for 5 years. Some nodding heads? Yes, I can see some nodding heads. So that wouldn't work for a service provider because I just have this asset just depreciating like a stone. So what we literally do is we buy the storage and we buy the compute and we buy the network switches. Literally, I buy in groups of 2 or 3 disks at a time. I literally buy a 1U rack at a time, but I probably do it once or twice a month. Right? That's just-in-time computing. Right? Because it allows me to have flexibility and allows me to be highly cost efficient. And with automation, I know I'm going to be able to set it up easily, and I know I can do everything right first time 100%. And that's the key driver about the way we do our business. And it's one day center. Sorry, there's a question.
I have a question.
How much overhead in terms of capacity do you have because you say just in time?
So it's very interesting. So the question is, how much overhead do we generally run at? Because we don't know what a user might be wanting, because they might want a bunch of Exchange mailboxes or some personal desktops. What I do is I work on the principle that we kind of run with enough capacity to do, say, 200 virtual desktops instantaneously extra. And I work on the principle that anybody who's going to want anything larger than that actually isn't going to be signing a dotted line with a credit card, and I'm going to get 7 days' notice. If you think about it, here's the real world. No one does a 1,000 mailbox deal like that. Yes, and I know that for my hardware supplier, I can physically get the tin in 4 days. Exactly. Yes, exactly. Yes, exactly.
Yes.
None of you are going to give me a 30,000 user mailbox contract like that. Love if you did, but you're not. Yes. So the reality is, I have enough headroom to deal with the people who are going to credit card buy and everything else, because I know literally, this is an important thing to understand. Tin turns up, it comes out of a box, someone literally just plugs it in. Plugs in power, plugs all the network cables into the same switch, and automation takes over.
Yes. So that's the same in the Microsoft data center. So Microsoft purchases more than 5% of worldwide servers nowadays for our data centers. So we have the hardware vendors coming in, just putting the servers into the racks, switch them on, and their job is done. Yep. The rest is fully automated, taking everything over. Yes, you need to have a certain capacity management, for sure.
And also, by the way, it's worth noting very briefly, when we say total automation, that includes things like setting up the BIOS and the remote access cards. So I touched on this database abstraction layer earlier. That's the key thing, because true automation, you have to be able to go from bare metal. True automation doesn't mean send a human over to the BIOS and start setting the boot order and the PXE boot, nodding heads, few people have done this, yes. So true automation is actually doing all of that in an automated way, which is entirely possible nowadays. And that's the big driver that allows us to drive these performance.
Good. So that's the final slide. So we have a little bit time left for question and answers, which I guess we started already.
Yes. And any other QA?
So this shows the big picture where everything comes together, from the infrastructure management, in the middle, the service delivery and automation, the little black magic, and then having all the applications running on it, our applications where we sell or where we earn money, and the different areas which the service consumer is interested versus what the service providers care about it. So, any questions?
Yep.
Yes.
Database servers with lots of capacity, lots of reason behind it.
Yep.
How do you cope with that?
You can build them with virtualization very easily.
Okay.
Yeah. So I think the real question is, how do you deal with very high compute workloads? And actually the big thing is now, and this really jumped forward in 2012, was that I can now build some very, very, very large VMs. I can build VMs with 128 virtual procs. It's 128, isn't it? 128 is the upper threshold. Where's the 256? I forget what the official one is.
Good question.
I can't remember if it's 100. I can't remember the officially it's 128 or 256. We've gone as high as 128. But if you think about it, there aren't many physical servers that have that many procs in it.
So currently, the limitation or the limits virtual server provide, or virtual server or Hyper-V provides is far away from what usually application needs. So there's not many apps which would ever do this. Of course, there's still always the discussion, if I have one server requiring this huge amount of memory and CPU, how much sense does it make to have it completely virtualized? In an enterprise, it's different than a service provider. Even as a service provider, you might have still some
There might, but I'm yet to see one. The real challenge, by the way, is actually storage IOPS. Is actually the real challenge. Now, that's actually where now it's really smart, because let's look at the old-fashioned way of doing storage. So you got some fiber channel, and you stuffed it in the back of your server. And basically, you're limited by the bandwidth of whichever generation fiber channel you're doing, and how many of those flipping cables you can dump in the back. But that's your real limit then becomes your PCI bus. Yes, that then becomes your real limit. What's very interesting if you start looking at the SMB3 stuff, and I'll be honest, SMB3 has a 2 or 3% performance hit, but it's actually much easier to scale out because you can start doing multiple NIC teaming. You can drive very, very, very fast I/O, yes, across that networking layer, and that's a much quicker way of doing it. Again, we can chat about this afterwards because there's a whole bunch of very deep conversation about this. But to give you an idea, under 2012 R2, we are now looking at building out 4 10-gig NICs, so giving us 40 gig a second IOP. Yes, just driving over SMB multi-channel. That's a stupidly large amount of bandwidth. If you start looking, if you take, for example, your dedicated situation. Pardon? Right. Okay, good. So let's look at the network piece, and then we'll talk about the disk. So if you use something like InfiniBand, yes, they're going even higher. But then, as you say, you then hit a disk performance issue. Yeah. So this is why. So let's just summarize this very briefly, because actually, what these gentlemen were all saying is, well, you've got all these pieces, all these moving parts. And this is why you have to look at the end-to-end solution. Because actually, the disk problem becomes mitigated with caching. You start putting stuff into RAM cache at the storage layer, and with tiering and with deduplication. Right? But that doesn't work if your network layer can't drive it. Yes? That doesn't work if your hypervisors haven't been scaled in a way that actually makes them highly available. Right? And none of this is relevant if actually you can't pump the actual workloads out to the user's machines properly. So actually what's really wonderful is that we've just had a microcosm of exactly the challenges that the modern data center faces. Yes? Which is about stop going, I've got this database over here, and start going, I've got 10,000 users who want to use an application, and actually this application needs to run at the correct speed. What's the best way of building a solution? And that's the way to really kind of take the paradigm shift, if that makes sense. Yeah. But we can deep dive on some of those other subjects later if you like.
Good.
Anything else? Or are we out of time?
Yes.
We're out of time.
Okay. So we are still here to answer some questions offline, but the session, we reached the time limit. Thank you very much. I hope it was helpful. Thanks a lot.
Thank you.